and thanks for joining us. Got something pretty interesting to talk about today. Um, Design automation and Hagerman's Automation Connection. So what we'll be talking about, I want to provide at least my definition of design automation. It's a pretty general term. So the idea is to kind of explain what I mean by design automation and kind of the context of today's presentation. Um, we'll talk about some of the benefits of design automation. Some of the benefits are self-explanatory. If you've ever looked into this, it might be a review. But I want to make sure that we're all on the same page in terms of what we can get out of design automation. Um, I also want to talk about a very important topic, which is why design automation implementations can fail. Here at Hagerman, we've helped people a lot over the years with design automation initiatives. Um, a lot have been successful. Some of them ultimately haven't. And I do want to make sure we understand why, because if you're thinking about getting more into design automation, it's important that you approach it the right way, and knowing where things can fail is important so you know what to avoid. With all of that context and background, I then want to get into the new product that we're talking about this morning, Hagerman Automation Connection, what it does, what its purpose is, and how it can help you meet your design automation goals. And then just make sure you're all aware as we wrap up how we here at Hagerman can help you, not just with automation connection, but really with any step or any phase of your design automation initiatives. And feel free to ask questions through the GoToWebinar interface. As we go, I'll keep an eye on the questions as we go, and if it makes sense to answer those questions in context, I'll do so. Otherwise, I'll address those at the end of the presentation. Right, so let's start with the definition of design automation, at least my definition. It may seem, again, kind of obvious, but design automation in this context is the use of software to automate what are traditionally manual design tasks. And some examples, it could be as simple as making design decisions. You could have an application that you can input some design parameters, high-level design parameters, let's say, and then it will spit out some sort of lower-level model parameters or geometry parameters. Maybe you design tanks, and you've got certain criteria in terms of volume and pressure requirements, and that will tell you certain things about the tank. And people have been doing that for a really long time. A lot of our customers will have little tools like that. It could be as simple as a spreadsheet, where you've put in some formulas that you use so that you don't have to do all that math every time. Some of our customers have gotten into creating CAD models and drawings. These days, I think that's what a lot of people mean when they talk about design automation is I want to make drawings automatically, or I want to make models automatically. And that really is the goal of our Automation Connection product. But it's also part of a larger design automation, I guess, environment where you may also need to do things like create estimates for quoting. That's a really popular application to tackle with design automation because quoting is bidding for work. You're not getting paid. There's no guarantee that you're going to get paid for doing that work. So you really need to minimize the time you can spend on all of the artifacts you need, be it a drawing or an estimate. You need to minimize the time you spend on that while maximizing the potential to earn the business. And so automation is a really good approach when you're trying to do quoting. But then also, for example, generating bills of material. You've got an inventor assembly. You need to buy things to make that. You need to make items. You need to communicate, material requirements. Automating the generation of those bombs and the handling of those bombs, I consider that design automation as well. It's also important to understand that design automation, um, it's not necessarily full automation. It's not like you push a button and then a million things happen, and then the end of the process is your deliverable, and there's no intervention in between. Um, Design automation can absolutely be semi-automated, where what I mean by that is maybe you start with inputting some values, and that leads to maybe part of your model output that you then complete with manual effort. Um, I think it's important to understand that, if you've been looking at design automation and you think, well, our product is too complicated, or it'll be too much work to automate the whole thing. You don't have to do the whole thing at once, and you don't have to do it in such a way to where it's 100% automated. If you can remove 10%, 20%, 50% of your daily effort, because automation eliminates repetitive tasks, there can still be a significant return on the time you invest getting to that point. So don't think, because we can't fully automate our modeling process, that we shouldn't even try. Most people have, some things that they can automate when they really look into it. And it could be something as simple as, automating property information so that information can carry downstream. There are a lot of things you can do. And on that note, the needs people have for design automation, they vary widely across the map. So I'm often tasked to help our customers determine, what it's going to cost to implement design automation. And the first question really is, what do you need? And what do you need this automation to do for you? Because that's going to determine complexity, cost, how realistic it is to meet the needs that you have or the expectations that you have, right? But those needs really do fall on a spectrum, I would say. The easiest is usually generating a bill of materials. A lot of companies have what are commonly called configurators, where you input some design parameters and some business logic is executed, and that leads to at least a preliminary bill of materials. The goal there is often to get an estimate for a cost so that you can quote, right? Configurators are very popular, and in my mind, they're usually the easiest to implement because it's all code and decision making. And there are lots of nice tools off the shelf that let you implement very common business rules, like if the overall length of our assembly is X, then we're going to need Y number of panels, and the panels cost Z amount. Therefore, our material cost estimation for this is A. That's all largely math and some basic decision making. And so those are pretty easy to implement, pretty easy to code. And so that's usually the easiest kind of thing you can do. From there, if you need more than just a bill of materials, you're usually talking about some picture of the product. Now, that could be a 2D drawing. The focus of our presentation today is largely on Inventor, but a lot of people still automate AutoCAD. AutoCAD is pretty straightforward to automate simply because a lot of times you're just putting blocks into a 2D drawing or drawing lines, arcs, and circles. And while there can be a lot of effort getting to the point where you're drawing the right things, it still is relatively straightforward because you are drawing, and generally you know what you need to draw. Automating in something like Inventor or a parametric modeler in general can be a little bit more difficult, if only because to make it as easy as possible to automate, you generally want to have some input parameters, and then the model itself doing things just the right way in the parametric CAD tool like Inventor. You need to model the right way, you need to put things together the right way. You rely on the CAD software to do the model updates, the drawing updates. And so that can be a little bit more difficult than AutoCAD, but it's easier for a non-programmer to do that. And I think we'll talk more about that when we get into what Automation Connection does. And things like iLogic make it easier for a everyday CAD user or engineer to apply business rules to their models, to make it easier to start to automate those things. But regardless of how you're doing it, automating models is more complicated in my mind than automating bills of material. And then from there, if you need to automate drawings like 2D views with annotations of your models, that's where it starts to get anywhere from, I would call, somewhat difficult to very difficult, depending on the drawing. And I break those up into two different categories, sales drawings versus production drawings, because sales drawings it's often good enough to just essentially be a pretty picture. It may not have to be to scale, maybe a few dimensions, a few annotations. The idea being you're creating something to help a potential customer decide to buy from you. That can be a lot easier to produce, that kind of drawing or deliverable, compared to what I would call a production drawing, which is what someone would need to build what you've designed. Production drawings are typically busier. They have more annotations. They have more dimensions. They usually need to be to scale or should be to scale. And it's harder to make it look like a production drawing was created by a person. And so if you've, if your business has been working for 50 years on drawings that look correct, and you suddenly start feeding the process drawings that are usable but look a little rough, it can cause problems. So, drawings are absolutely a worthwhile end goal, but they are usually, in my mind, the hardest thing to automate. Right? And now our Hagerman Automation Connection, and really the focus of our presentation today, we're not going to be talking so much about the BOMs. So I've used that term, the name of the product already a few times, Hagerman Automation Connection. I do want you to get an idea of what the product is at the end of today's presentation, also what it is not. And it is not a configurator. So Hagerman Automation Connection does not have any sort of rules engine on its own. It is not designed to let you capture business rules or generate bills of material or capture the logic of your product. It's designed to facilitate especially the end of the design automation process. And when I say the end of the process, in my mind, design automation really is and should be approached as a process or as a journey. The design automation efforts I see fail very often are those that try to do too much too quickly or start in the wrong place. And I don't think if you're looking at starting a design automation project, don't think you have to do it all at once, and don't think you have to, put a few people on a project for 6 months or a year, and then they come back and provide you a solution. It's done best when you start small, in my mind, and use each part of the process to build ROI. So you can start, for example, by automating parametric models with Inventor. If you've got a configurable product or like an engineer to order type product, and you find yourself a lot of times doing a copy design in Vault, and then opening up an assembly and changing a few things, and all of those things you changed are based on business rules. So this new order I have in front of me, here's what the customer has ordered, and because they ordered this, I need to go and change these parameters, or I need to change this part out for that one. And I'm following the rules I always follow. I'm more or less just pushing buttons to make these drawings so we can build this product. You you can start just by minimizing the time it takes to generate the new model from the new inputs. And that can then be built upon so that later on you can automate that and maybe take away the need to even touch the model. So sort of a side path on the automation journey in my mind is automating what I call outputs, meaning say a PDF of a drawing or a step file of a model, a bill of materials from a parametric CAD modeler, automating outputs. So you generate your models, you generate your drawings, and now you need to share a PDF, a step file, a flat pattern of a DXF. Automating those things can provide very significant return on investment and give everyone in the business more appetite for automating more things. If you can show value and saying, hey, we've got this thing that automatically makes PDFs and DXF for us, we'd like to start automating more of the process. This is a very popular place to start. It's a very high return place to start, and it can really help kickstart other initiatives that you might have. Now, once you get to the point where maybe your parametric models are, your models are mostly parametric, you might get to the point where you're maybe automating your model generation. Now, this part of the process starts to get a little bit complicated depending on how you do it. Rather than just, going into your model and changing parameters, it could be you start to use iLogic and you generate an iLogic form. And that iLogic form has maybe your high-level design inputs and then rules that you've captured via iLogic do the parameter changes, right? So in my mind, you've got your inputs, which are what the customer might say that they want to buy. How long is it? How wide is it? How many, pieces can it hold? Things like that. Those all translate into model inputs. And so in this first step in parametric models, you as the engineer are maybe translating the design inputs to the model inputs. At this stage of the journey, now you're starting to take your knowledge as an engineer, capture that in software, and automatically translate the design inputs into the model inputs. And then the models themselves, after you place the design inputs into software, the models get generated automatically. And then maybe you place your drawing views manually and you do your dimensioning and all that kind of stuff, right? And we do have a number of customers that reach this point, automating their models to some degree. And it can certainly save you a lot of time. And I think this is where, though, a lot of design automation efforts, I won't say stall out because it's certainly a viable end goal, but you could take it further if you have the resources to do so. Getting into automating drawings. This is usually a little tougher. There are pretty good tools in Inventor's iLogic toolbox now to help you create drawings that as you change model parameters, they update properly. Now, Inventor has always been able to update a drawing view based on model changes, but depending on how variable the thing is that you're drawing, view sizes might need to change, scales might need to change, you might need to rearrange dimensions, balloons might fall off of an annotated assembly view. iLogic has some pretty good tools to make it possible to automate drawings. I would say many of our customers are not to this point yet, other than maybe some pretty straightforward stuff. But this kind of gets back to the previous slide I had where automating any kind of drawing starts to get really complicated. And so we see there's a pretty big step here. Right? But the biggest step of all, in my mind, is the last one, getting to full automation, where you can place your design inputs into some interface and then press a button. And then after a few seconds or a few minutes, the end result is you have the outputs, PDFs, DXF flat patterns, step files, bills of material, right? This is the last step because you can't really do this last step. You can do automated drawings even with iLogic, but you can't get to the point where you're fully automating the process without programming knowledge. Because someone has to code an interface, someone has to, if you're using Inventor, has to direct Inventor to open this assembly and modify these parameters and save off this PDF. You need software to do that. You need someone who knows how to write software to make that happen for you if you're going to do it yourself. And that's what Hagerman Automation Connection will do for you. It can take, if you're at the point where you have models that can be automatically updated based on parameter input, Hagerman Automation Connection can take input from some user interface and tell Inventor what to do to generate your outputs. And we're going to see examples of that in a little bit, but that's fundamentally what it does. It helps you take this last very large step and make it something that is off-the-shelf software. It is, a known quantity. And if you've got this last step figured out, and if it's easily attainable, it can give everyone a lot more appetite to take on the beginning part of the process. So I'd like to take a little break here and ask a poll question because we have a lot of people here, and I'd like to get a sense of where everyone is on their design automation journey. I am making a basic assumption that if you're watching this webcast, you have some interest or some need in design automation. Maybe you haven't started yet. Maybe you are maybe at the parametric model stage. I'm going to go ahead and launch the poll now. So again, maybe you haven't started, but you know you need to. Maybe you have generated parametric models, and meaning, if I change parameter A, parameters B and C update, and my model updates, my drawings update. And then maybe you're at automated or semi-automated models where, again, taking high-level design inputs leads to a model that is already generated. Or maybe you're all the way to automated drawings or even full automation, where you do have a solution where you take input from some business system, and then out the other end of maybe a black box comes outputs. So we're starting to see a lot of responses come in. We're going to give it maybe just another 15 or 20 seconds. Okay, and so it looks like we're pretty stable now. I think we're going to go ahead and close it up. And then I want to show you the results here quickly. This is kind of as I expected. Most people know they want or need to do it, but they just haven't yet. A lot of people are using Inventor parametrically, and I think that's important. And there's a good question that just came in. What's the difference between a parametric model and an automated model? And I do want to make it clear, those are my distinctions. In my mind, a parametric model is you're taking advantage of something like Autodesk Inventor and what it does inherently. You're relating parameter A to parameter B through some equation. You're making sure, like, if the width of this box, if a basic design rule is the width of this box is always half the height of a box, you relate those two dimensions together. It is absolutely possible to use Inventor a lot like you would use AutoCAD, where all you're really doing is drawing 3D models. Nothing really behaves parametrically. You're just drawing things in 3D to get to a 2D drawing. People still use Inventor that way. I think maybe a lot of people use Inventor that way. And even though they know they could take advantage of parametric modeling, they haven't quite gotten to that point. Now, what I would call an automated model is where you are not as a designer, but built into the models themselves, not just basic geometric relationships, but actual business logic. So if you're using iLogic rules that say when someone puts in an overall length dimension, that these 5 other parameters have to change, or especially if there's decision making, like if the number of rollers we've specified is 10, then the length of this thing needs to be 50. If the number of rollers is 20, it needs to be this, right? You're adding logic. That to me is an automated model versus a parametric model, which is just taking advantage of the built-in parametric relationships. Okay, so let's talk now briefly just about the benefits of design automation. I want to make sure we clarify this. In my mind, there are 2 big ones. There are lots of ancillary benefits. The 2 big ones are productivity, right? We're all crazy busy these days. Since the pandemic and sort of the upheaval it's caused across lots of different industries and supply chains, and with demand being crazy in a lot of areas, a lot of us just have way too much to do, right? The more time we spend on tedious, repetitive tasks that could be automated away, the more time we'll have to add actual value to the process. A lot of times it's all we can do to keep up with the basics though. So design automation can take, say, the 40% of your product that is the same thing every time, just put together a little differently, and then customer specific drawings. That's the kind of stuff you can automate, often in a pretty straightforward way, so that you can focus on, more important tasks. But I think also an often overlooked, but more important benefit is accuracy and consistency, right? Most engineers or people using CAD have a set of rules that they follow when they're designing a product. In some cases, there are very clear, well-defined rules that just need to be followed. In some cases, it's more experiential, right? In cases where you have well-defined rules, if you communicate those rules to a computer, those rules are going to be followed the same way every single time. If a person's doing it, if they've got enough experience and they know the rules, and they've had enough coffee that day and enough sleep last night, they're probably following the rules the same way most of the time. But we're all human, right? Mistakes are going to get made. If you can turn over some things to a computer, and the computer, you get the computer generating correctly, it's going to generate it the same way every time. So it's very often, so you'll look at a design automation project and think, yeah, this will save us X amount of time. And that's certainly a viable way to gauge the benefits, but you should also look at what adding accuracy and consistency to your process will do. But they both add up to the same thing, which is more money, more profit, whether you're saving money on labor cost and design, or whether you're saving money because you're not cutting metal incorrectly or shipping the wrong product. Design automation can absolutely pay for itself. And it has to, or you shouldn't do it, right? So you really do need to ask yourself some questions, because the benefits, I think, are pretty clear, but design automation is not for everyone, right? And it is more beneficial to some environments than others. So you do need to ask yourself some questions before you actually start on this journey. And, about a third of the people that are watching think they need to, but they haven't even started yet. So you do need to ask yourself these questions before you really get serious about it. Do you have repetitive tasks and processes? Do you find yourself pushing the same buttons in the same order every time to get to the same result, just with slightly different numbers? That's a good indicator that you should automate. If your product is configurable to specifications, that's a really strong indicator. If you have defined standards, if you've got rules written down somewhere that says when X is 2, Y is 14. It's a design rule. It's the way our product works. Again, that's a good sign. Or I think almost everybody, qualifies here. If you need to provide alternate formats to customers, internal or external, right? Do you need to make a PDF? Do you need to make a DXF of a flat pattern? Do you need to generate a bill of materials for somebody, right? And this automation could be very simple. Again, just automating PDFs. It could be as complicated as take input from a website and immediately deliver to the customer a PDF showing what they would get if they ordered, right? It runs the gamut. And we're just about to get into what Automation Connection actually is, but just to sort of wrap up, the design automation discussion, if you're thinking about starting or if you're in the middle of a process, which, some of you have automated or semi-automated models, some of you are automating drawings, some of you are even to full automation. It's important to talk about why these projects can fail so you can avoid those failures. The biggest one in my mind is really lack of resources. A close second, I think, is lack of direction. Starting in the wrong place and executing in the wrong order. You may say, well, our engineers spend 80% of their time on making drawings for the shop. So let's automate our shop drawings. Well, that can be a really difficult proposition. So it might be better to start with something that takes your engineers less time, but provides a better return on investment. And then you can also often build on that to reach the goal you might have started out with otherwise. But it's important to start in the right place and to do things in the right order. Another big reason they fail is unrealistic expectations, especially on the drawing front. You may not be able to get to a perfect looking drawing, or you may be able to get to it, but it may take you months of effort. Good enough really should be, in my mind, the first goal when it comes to a drawing. Now, you still need accuracy, right? So it's not like, well, as long as 80% of the designs are correct going out the door, that's good enough. No, they need to be 100% correct. But if you can get 80% of the way done and save yourself hours and hours per project, that still is a viable goal. So don't think you have to get to a complete automation or a perfect looking drawing. You need to get to good enough, which in my mind, engineering is the practice of good enough in my mind. So I think that should be familiar to a lot of us. The biggest reason why design automation projects fail, though, in my mind, is really a lack of resources. We have lots of customers who recognize that they could benefit from design automation. They've taken steps down the path, they've gotten training, but then ultimately they never quite get to where they want to go because they don't have time, right? Now, doing a design automation project, getting to the point especially of full automation, is a unique skill set, right? You need both product knowledge of the thing that you are automating, but also often at least some knowledge of programming or software or programming logic. And very few of the companies that I've talked to already have both in-house. Some do, and they end up being very successful in their design automation efforts. Rarely do they have someone on staff that can both write software and knows how their physical product works. So you may need to get help, right? And a question just came in, lack of training is an issue why many projects fail. And that's a really good point. And their question is, lack of good documentation and training materials are hard to come by. Can Hagerman help with that? So we don't have any additional training materials or documentation. And that's absolutely a very good point. It can be hard on your own to find where things might be documented. And that's where a company like Hagerman can help. We can do live training with you, get hands-on with you in your projects, so that we can bring our software skill set and our overall, say, CAD skill set and work with you and your product knowledge to come together to get you over that sort of those humps of automating your models and automating your drawings. You know, there are a few books out there, and I can respond with an email to Martin asked the question, with maybe some recommendations on specific books. I don't have any off the top of my head. We do use some training material for iLogic classes, and I think that training material is pretty good. But really, you need to get help from someone who's done it before, and we can help with that. Now, I will say a lack of resources. The underlying problem to that is failure to tie your design automation efforts to actual business goals, because we don't have time or we don't know enough to do this. That's because management hasn't given you the time or giving you the resources, financial or otherwise, to learn what you need to learn. If you can identify a business goal to tie your efforts to, like, we want to generate quotes, X% faster so that we can win, this much additional business, or we need to remove X amount of waste from the process, and to do that, we're going to need to remove, X amount of mistakes in the engineering department, right? You really need to get management on board. So that's how you're going to be successful ultimately with your projects, is to get management behind you and give you the time that you need to get these things done, right? And then another reason why it can fail, and we talk to customers about this a lot, they say we need a website where someone comes to the website, they build their configuration, and then they get a drawing out of it, or they get a price out of it. If you've not even started on the path, that end goal is definitely the end goal, and it can be very hard to reach, and efforts often falter. And part of why they falter is because it's hard to demonstrate and it's hard to show that there is a way to take that very last big step, right? And that's what Hagerman Automation Connection is for, to help you take that step, right? So preventing these failures that I just talked about, I kind of got into that a little bit already, but for lack of direction, get help developing a plan, right? Before you even get started, get help from someone who has gone through the process before, to help you plan out what to do and how to get there. Also, make sure you dial back your expectations. We just had a question a second ago. How do you define good enough? Absolute perfection assures no errors in designing elaborate fixtures. And again, what I mean good enough, not good enough from a standpoint of, is it correct? Because that has to be right. You're correct. The end goal, the design, has to be correct. What I mean good enough is you don't have to automate to the point where it's doing absolutely everything for you. You may still need some manual intervention in the process at some point. It may help you, automation may help you get to designing the fixture 80% of the way. And then the things that might be just too hard to code, or too hard to code just yet, you still do, a person still does. Or maybe your entire model can be generated, but your drawings are so complicated that it doesn't make sense to do that. Automate the models and then do the drawings by hand, right? When we're talking about automation, getting part of the way there can absolutely be a valid end goal. Lack of resources, right? Another question just came in. Can you work with existing code and expand or make it better? Yes. Contract with experts, right? In my mind, if you've got a design automation solution, you always need to be willing to invest in internal resources. You need to get someone on staff who understands the automation, or at least how it works, and be able to maintain it at least at some basic level. That is vital for long-term success. And here at Hagerman, when we work with customers, that is often our primary goal, is to enable our customers to maintain their own solution. It's better for everybody. But if you don't even know where to start, you're going to need some help, and we can help you with that. We could take your existing code and expand on it. We could take an old tool that you have and modernize it. There are lots of options, right? Again, the business goal thing, start with your desired business outcomes, right? What are our business goals for the next year, 2 years, 5 years? Will design automation help us get there? If so, get management on board, make sure they understand the resource requirements, which again, Hager can help with. And then when someone in management says, well, I need this done faster, it's like, well, we all agreed, right? This is what we need to do to reach our goals. You can keep things on track that way. And then a lot of this, when you're talking about taking that last step to full automation, the investment in internal resources in that step is extreme. Getting management to commit to a long-term plan when the end of the plan is so maybe poorly understood, that can be a real problem. And that's where Automation Connection comes in, right? So again, Automation Connection is a new product by Hagerman Company. And I think the best way to describe it is a CAD job processor. So Autodesk Vault has a job processor to make PDFs and DWFs. We're creating a job processor for CAD. It's very easy to implement. It's simple to use. It works with Inventor and AutoCAD both, right? Our focus is a lot of this, and especially the rest of the presentation is going to be on Inventor, but AutoCAD can be work with this tool as well. And part of the reason we're focusing on Inventor, especially in this presentation, is because Inventor gives you the opportunity to generate an intelligent model, meaning you apply your product knowledge using the Inventor tool, and then our tool takes those models and automates the creation of them, automates the creation of design outputs, so that you don't have to worry about the programming side and all of that. You worry about making your models behave, right? So why are we doing this, and why should you consider, a product like ours or getting our help with your design automation in general? All right. Well, we have literally decades of experience on staff. We've automated both Inventor and AutoCAD many times, doing things like safety storage cabinets, partition systems, bleacher systems, printing equipment, store fixtures, steel framing systems, walk-in coolers, a broad range of things that you might think would be pretty complicated. How do you automate a wall? How do you automate a cooler? How do you automate printing equipment, right? whether it's an entire product or part of a product, we've done the gamut, right? We've seen a lot of projects, and we can help your project be successful. Right? And we're launching Automation Connection, like I said, because this journey we talked about before, that last step is the hardest one by far, right? It's relatively straightforward to do parametric models, in my opinion. Automating models can be straightforward. It could be difficult, right? But the key is Inventor gives you tools where you don't really need to be a programmer to make that happen. iLogic is a fantastic tool. It's been around for a while. It's really gaining traction now. You don't have to be a programmer to use it. You don't need any sort of external framework or orchestration to use it. You build the rules and intelligence into your models, right? So an everyday Inventor user can become proficient in making automated models. Automating drawings is a big step, right? We can help you with that. But that full automation is by far the biggest leap. It requires automating the CAD application itself. You've got to have something orchestrating input from a user, applying that input to the right model, generating outputs, right? That requires programming. There's nothing really that I'm aware of out of the box today that automates that whole process in general, right? But that's what Automation Connection is going to do, right? That can be the biggest return on investment in a lot of cases, but it's also the biggest step to take. So that's why we have come up with Automation Connection. Right? So fundamentally, the way it works is you take input from some interface or some system. It could be ERP, it could be a web page, it could be a spreadsheet, right? And that information goes into a file somehow, into a folder on a computer. Our Automation Connection dashboard reads the contents of that folder, ingests the file, and then talks to Inventor or AutoCAD and says, execute this set of instructions, or in the case of Inventor, open up the model, update parameters that we've specified in this file, right? Generate these outputs, these PDFs, these bills of material, these step files, right? And those outputs go into a folder. So everything on the bottom half of this is automated. And so ultimately what happens is you take a spreadsheet, you copy it into a folder, a few seconds to a couple minutes later, you've got outputs in a different folder and you're ready to go, right? That's the idea. So all of this is the product. This is what you just install. You feed it a file in a particular format. That could be JSON, CSV, an Excel spreadsheet, right? And you get your outputs. So I want to give you a brief demonstration now. There's honestly not a lot to see, just because, again, it's all automated, right? But I want to show you at least working, show it to you working so you can get a sense of really what it does, right? There we go. So what I have some folders here on the right, and our design automation dashboard here. And I'm going to tell it to attach to Inventor. Now this is actually going to start an Inventor process for me. There are ways we can get this set up, and I think the eventual goal of the product is also going to be able to run as a service, so it doesn't have to be monitored. But we've got an Inventor process here now, right? And I'm going to put these side by side so that you can see, you know, what how this works. So here's an example of a spreadsheet. Now, the first page of this spreadsheet is just some inputs, and a lot of people have spreadsheets like this, right? Where you've got some design inputs. Maybe you put in a job number, a customer name, and then the parameters of the design itself, right? So maybe we know the customer's ordering this, it's 35 feet long, it's 25 feet wide with a depth of 18, right? And whatever other parameters you put in. Now, the rest of this spreadsheet ultimately would be hidden to users, but the rest of this spreadsheet is designed to drive automation connection, right? So the inventor parameters that might need to change, information about the job, where do the outputs go? What assembly should I manipulate? What outputs do we want? I want a step file of the assembly. I want a PDF of the drawing. What other inventor files need to be updated, right? Do I have part file drawings? Add these to the list. It will update and make copies of the part files. Files that shouldn't change, right? Content center files shouldn't be copied, so we don't want to copy them. iLogic rules we want to implement. We want to spit out a bill of materials, right? So this is what the input looks like. And when I copy this into the input folder, that's when automation connection, you're going to see it here in just a second, it's going to disappear. And then Inventor's going to start working. So you can see down here on the left, it's now going to open this assembly. It's going to provide the input parameters from the spread. It's going to read the spreadsheet. It's going to update parameters. It's going to make a copy of the model, making copies of all of the files that need to change as a result of this design change, automatically open the drawing, update it, and then spit out a PDF of the drawing, a step file, and a bill of materials, right? And so if we look in our outputs folder, right, this was our job number, and we can see we have a complete inventor model, including a drawing. These are all new files, right? So they're distinct from the original design. We have a PDF of the drawing, right? And we have a step file, and we have a bill of materials ready to go. And so all you need to do to make this work for a given assembly type is create the spreadsheet and then make sure this structure is followed. And this is the kind of thing, if you bought Automation Connection, we would certainly help you with. We have a standard service for that, so it's a nice known fixed cost. But then let's say, okay, we've got a part drawing, we also want a PDF of that. All you have to do is say, here's the name of the drawing, here's the source file, right? Say part 1. And we want that to be a PDF as well. Now it would also open up the drawing and make a PDF of that every time you run one of these spreadsheets. So you don't have to be a programmer to fully automate the process. Now it's not just spreadsheets though, right? I've got another example here where I created a little simple web page where I can actually capture some inputs here. And the way this web page works is it uses the same engine, right? When I hit the build button, what you'll see is back here, a file appeared in my little test folder, and Automation Connection does exactly what it did for the other model, right? It opens up the model in Inventor, it updates it, generates the drawings, but in this case, the website is designed to read the folder those outputs would go into, and when they become available again, the website will say, you're done, okay? Now I could download a PDF and take a look at it, right? So again, this would be a way you could implement on-premise, a way to drive Inventor with a web page and get outputs to the customer. So this would ideally be internal, but with proper security setup, you could expose it to customers as well, using Inventor behind the scenes to drive the process. So that was a very short example. But again, you generate the inputs, be it a spreadsheet or the results of a web page. Our tool reads a file, updates a model, generate outputs, and puts them in the right place. We can do IGES files, step files, SAT, any format is going to be built into Automation Connection. And you don't have to write any code to do that. You just say in the file, here's the source document I want the step file of. Here's where it should go and what it should be called. That's all you have to do. Automation Connection will generate it for you. You don't have to write any code to make that happen. Okay, so we're approaching the top of the hour. So I just want to make sure you understand what's required to use this tool, and then we'll get on to questions. So you do need CAD. This does not include any license of CAD. You also do need a product line that can be driven by automation in some sort, right? If everything you do is 100% custom, it's probably not the tool for you. You also need to have some way to gather user input. We aren't yet providing a standard way to do that in terms of like, you know what, also we'll build a web page for you. We don't do that. You need to either have a spreadsheet people can fill out, or maybe your own website that generates something. You need to get the data in a format that our tool can use. And there's a standard format. So you'll know, however you're collecting input, how you need to transform that to use our tool. We can certainly help you get there if you buy the product. Ideally, you would also have some level of automation in place, either iLogic or iParts and iAssemblies. But if you're not there yet, which most of you aren't based on your poll responses, we can help you get to the point where you can take this last big step and automatically generate all these outputs from your CAD models, right? So next steps, evaluate where you are on the path. If you're just starting, remember, look at your business goals and determine if the business goals can be met by design automation. Develop a plan, and we can help you with that too, to help you understand what's realistic, when it can happen, what your ROI will be. We can help with all of that. If you're on the path already, do you have a plan? Or are you just sort of going, ad hoc? If you are, how's it going? Do you need any help, right? And if you're almost there, if you're automating models and drawings, but you haven't taken the step to full automation, what's stopping you? If it's because we don't have the in-house knowledge to do that, Automation Connection can help. Right. Okay. So some questions that came in, I addressed several of them as we went. Let's see. I am gonna distribute, we have a couple people that have asked for a list of book resources. I'll put those up, and I'll see about making a blog post as well with what I think are some pretty good resources for learning iLogic and design automation. We can work with existing code and make it better. We can generate IGES and SAT files. We're not ready to share costs just yet. This product is still technically in beta. But we can certainly talk to you about the application if this is something that you're going to need. We'd love to talk to you about it, get a sense of how you're going to use it. And then certainly we could get you a quote for the software as well. And we'll give it just one more minute for questions. I haven't seen anything else come in just yet. And if you do have any other questions, you can feel free to reach out via our website or to your Hagerman account manager, and they can get in touch with me or somebody else here at Hagerman to help answer them. But yeah, I think we'll go ahead and wrap it up there. So as a reminder, you will get a link after this with a brief survey to fill out some information and ask how we did. And there will be a recording as well. You'll get an email link to the recording, and then it eventually will be up on our website on our webcast on demand. And thank you so much for attending today. I really appreciate it.